All right, so we're going to be looking at the Graphing Calculator app. We've talked about it in an earlier video when we did linear equations, so I want to do a quick review of that in case you're joining in on this at a later module. But we can download a graphing calculator to our smartphone. The one that I like and I'll be demonstrating is Calc 84, and that seems to be more of a an Apple product, so you might have to find a different, and you can find a different version if you prefer even to this one. So there's all kinds of free apps in your app store, and on Android, one that I've used is Class Calc, ClassCalc. So you may want to see that one. I think it's pretty similar to this. So if you want to download that, and I want to show you what that looks like on my phone, it's pretty much the same functionality of a handheld TI-84 graphing calculator. Only thing is, I think it might even be better where it's touchscreen, and you can move the points that way. And also it's handy, you'll always have that with you. The other thing to say about this is you might be taking a test like an ACT or even a math exam where you're not allowed to have your smartphones present. If that be the case, you should be able to move from this to the handheld, which sometimes can be borrowed from a friend or checked out of the library. We have some of these available in the library for checkout. So you should be able to switch from this to the handheld fairly easily because they are replica of what you'd see on the handheld. Alright, so download that and follow along with me. Let me talk to you about the buttons. The main buttons that we use are along the white row, that first row you see. Y equals, we have to write an equation for Y before we can use the graphing calculator. Window will let you adjust. Its default is a 10 grid and counting by ones. You can see that's true on the Y scale as well. We can change that though if we need to. If it won't fit in the window, sometimes we have to adjust. Zoom helps us. There's stand the 10. It takes also zooming in and out, and various options there for zooming. Let's see. Trace will allow you to use these buttons up, down, left, right. I guess I just need to go left, right on this one, but it'll let you move along the line, which we may use that some. And then graphing, graph lets you it displays the graph that you have input. The next important row, graphing features, these are the second functions. So, and it's hard to see here, but above these white buttons, you have some second functions. And I want to outline those for you here as well. Stat plot, I don't use that much, but here's where it is. It lets you design various types of graph, which you may use more in statistics or something, different plots. Table setup, that's a good one. That allows us, if we have extreme values that aren't fitting, we can tell the table to start, instead of at 3, maybe start at 30, that we have big numbers and that's not working. And maybe if we want, to count by tens or something, if it's a big problem. Or on the other side, we may want it to count by halves. If we need to see some of the fraction decimal from the fraction values, we'll need to tell our table setup right here to count by half, or even count by 0.1. I need some decimal values to try to figure out domain and range. Otherwise, the default is it counts by 1, so you don't see those fraction x values, and unless you set it up that way. Format, you can see I'm not really going to describe that one. We don't use it for this class. D, this is where most of our functions are, though, for what we're going to do in this class. Calculate. Under calculate, we can find the 0, which is the x-intercept. That's a good one in x-intercept. And then minimum, maximum is on there. You've got a minimum and a maximum. Those will be used in today's lesson for our parabolas. And then intersect. When you do chapter 5, when you're looking for where two equations cross, you can do, if they're linear equations or equations you can use this for, you can try to figure out where they cross one another. And let's see. Table's always good because these are your table values. If you were working these problems by hand, it gives you values. All right, let's get so. So we did a bit of a baseline in our line. So when I go back to that, you can see that's what I have here actually. Let me delete that little point. All right, so I solved this equation, and now that lets it in the equation. If I'm looking for intercept, it makes you do left bound, hit enter, then move over to the right side of that before it tells you the answer. I think I was under intersect. I meant to be under 0. So in 0, or anything is asking you where some point is, it makes you move your cursor over to the left side, left bound, and then see where it says right bound? Move it over to the right side, hit enter, and then it will tell you where the 0, where it crossed that x-axis at. And then it would have done that for intersect as well if we were doing chapter 5 where 2 lines cross. It can do intersect that way. All right, so moving on to activity 2. We want to talk about parabolas in this lesson. So let's put in, the good news is a lot of times these are already solved for y. We won't have to do that part. So let's put that into our calculator. Use this negative sign down here, not the subtract sign when you put in a negative. And then remember our x is this third down, second across. X, and we have to square that, and then plus 3. So get that input, hit graph. All right, so we can see that is the parabola shape. We notice it's upside down, and we notice that the negative, we expect it to do so. We notice that it's vertically shifted 3 places up. Now I'd like you to use your trace to practice trace to estimate the vertex, the x-intercepts, and the y-intercepts. So pause the video if you like. But I'm going to use, you can either use your touch screen and do that. Or if you're going to do trace, actually trace is a main function button. Then you can use your arrows. You can try to trace around it. And it sort of looks like about negative 1.7 there. And then on this side it looks like positive maybe 1.7. But I can't tell for sure in the trace. I can kind of just estimate. The vertex, the highest point, look like about 0x and up almost 3. It's kind of what we thought. So practice with your trace. It'll let you kind of estimate. If you want exact values, you have to use calculate. So we go into second calculate. Let's do the maximum first. It's a maximum because it's a high upside down parabola. So let's look for maximum. It makes you do left bound. So go where, I think it's right there, right? We think it's that highest point. That's our maximum. So we cursor over to the left side of it, hit enter, and then cursor over to the right side of it, hit enter, and then it will say, here is your maximum point at the point 0 for x, 3 for y. And that confirms. This other is telling you just a point where your cursor's at currently. Just gives you the current location. But the maximum's that second line there, 0, 3. Also, let's see. So we did 2. What is the parent equation? We always talk about the parent equation when we get into the shifting rules. And the x squared is what I would call the parent of that. You know, it is a shifting of the most basic equation, y equals x squared. So that's what I'm talking about for the parent. And in this section, we're talking about all parabolas. That's the parent parabola there. It's the most basic form. Whenever we have a parabola centered at 0, looks kind of like the basic shape there, that's the parent. So this is related to the parent, right? But it's flipped upside down and it's moved up 3 places. So that's the effects of each of the values around the parent. I'm going to ask you to do each of these in a minute on an example. Then determine the domain and range. Domain means how wide this thing goes from left to right. Now the screen ends here in our 10 by 10, but I want you to know that parabolas keep going. So a sketch of this, if I were drawing it on my paper, would look like moved up 3 places, upside down. But I would have arrows. You don't get to see that on your screen, but there are inferred arrows. And this graph, as it gets wider and it's going down, it is getting further over left, further over right. There are x values from left to right. Also, we know in a parabola, even our changed up parabola here, you can plug in anything x. Always get a real answer for y. There's no restrictions on the x. So that's how we describe domain, how from left to right the graph would be visually, but also domain is what can you plug in for x and get a real answer on the side. For range, though, this does have a actual high point there, and that's where the maximum occurred, moved up 3 places. So the second part of the vertex, this was 0, 3 for the vertex. The second part of the vertex will help you figure out what to write in for the range. That is the highest point, so it's negative infinity, high point of 3 with a bracket because it includes that point that it hit. And then if we were together, we'd exchange work and working groups here. All right, so I'd like you to try to repeat all those steps with a practice problem that I'm going to give you. I would like you to do this with y equals x plus 2 squared minus 3. I'd like you to graph and repeat all the questions that we did on the last problem. So pause the video. I'll be moving on with it. Okay, so I've input that to my screen. I hit graph, and now we look at that. Parabola still. Can you figure out domain, range, minimum, maximum? Let's see. Minimum is going to be at this point where I kind of estimate it to be, so I can kind of estimate it by moving my cursor on that. Looks like about -2, -3. And actually, from what we know about the shifting rules, this moves the graph back 2 places, and this moves the graph down 3 places. So that's what we would expect from investigating it other than that. And that's what this says as well. Now, to know for sure, we hit the calculate. We expect this is a maximum this time. So we hit maximum, and it says go to the left side of it, hit enter, cursor to the right side, either with your side buttons or your smart screen. And, oh, wait a minute. It's a minimum. Did I hit the wrong one? Oh, that's good for us together, right? Let's do calculate. I should have said minimum because it has a lowest point. Sorry about that. Let's do it again. So to the left side, to the right side, and there. It will do it now that I've punched it in right. So there is a minimum at -2, -3 as we suspected. And it will tell you that minimum, M-I-N, in the second line. Another thing we could find is the zeros. There's actually 2 zeros on this because it's got 2 x-intercepts. I think there's one about there and about here, the 2 x-intercepts. Now, how would we find that without our method here? We would have to use the quadratic formula. That's how we find x-intercepts of parabolas or quadratics. It's by the formula. So this will be much easier. So I go to the left and the right side, and it tells me there's a 0 at -3.7. So it's not a nice crisp point, but we'd have to convert that to, it's probably a radical answer or irrational number, so we may still need that formula yet. Now there's another 0. I think it may have let us do both of those at the same time. So let's see if it will. If I go to the left side of where I think both zeros are and the right side of where I think there's 2 zeros. Let's do this again. Yeah, it will. It'll do both at the same time. There's 2 zeros, -3.7-ish and -0.26-ish. Now, we would prefer to have the more exact answers, and we'll have to convert these. And we might actually have to, if that's the question you're asked, is to give the exact values of the x-intercepts. You may still need the formula, as it turns out. And so what that looks like, or we could solve this for x, the x-intercepts are always found when y equals 0. So what would that look like? You could either put this in standard form of a quadratic and use the formula, or we could actually solve it like this. Let's look at that. And then square root, there's where the radical comes in. Plus and minus, right? And then minus the 2. So it's square root of 3 plus and minus. That would be your exact error for that one. We were able to use the square root property. Also know the domain is -infinity to +infinity for parabolas, but the range is affected by where the second part of the vertex is. So this parabola is upright, so it has a minimum point at -3 and then goes up to +infinity. All right, hope this helps.